All right, so let's take a look at what we're doing today. Nature of Code, Chapter 4, Particle Systems. This is something that I didn't realize when I first started reading this, is that particle systems came about from Star Trek II, Wrath of Khan. There's that scene when the Genesis device is fired at a planet and it consumes the entire planet in fire before turning it into a really awesome, livable, breathable, Earth-like system. And that fire, apparently they use tiny little pixels moving around randomly and then dying, and they termed that particles, which is really cool. Nice bit of trivia. So what we're going to do today is we're going to create a new class, a new particle class, which is going to be similar to our mover class from before, and then we're going to display it to the screen, and then we're going to create a table of them and then put them all on the screen and sort of see what happens. So the plan is, the first one we're going to create is this, where it just creates a single particle and launches it. And we can see, I guess they have this all right here for me. We can see it right here. Now, of course, I also have the book, Nature of Code, which offline, that's what I've been going through as I'm reading this. But the online version, which is available for free, but it's also a pay what you want scale. All right, let's get started. We're going to create a single particle. Means we need a new class. I'm assuming I'm going to need a vector. Okay, so what we've got here in this class particle, the particle constructor, it looks like, is bringing, oh, he's shorthand, L for location. I don't really like that. What we can just do is just say location, and this will be okay, so that should give us a good basis for particles. Okay, so what do I want to do? In this constructor, we're going to set acceleration. It looks like we're starting it at 0x, but a downward momentum of small amount. Now I'm probably going to multiply that by delta time, so I could set that for a little bit larger. Two, 0, and let's just do 1. Velocity. Looks like we're telling it, okay, we're setting the velocity to begin with. Oh. looks like we're setting it to be a random number between -1 and 1 for x-axis, so left and right, and -2 and 0 for the y. Oh, because we want it to go start. Because if we look at this, it starts up a little bit. Oh, that's cool. Say curious if these numbers will actually be good for us, or if we'll have to tweak them. Most likely we'll have to tweak them. And this is going to be -2x and nothing on the y. Oh, sorry. Yeah. That. Then the location, so t dot location. Now here's something interesting. He's doing a .get to get a true copy of it because he doesn't want it to location. So even though this location goes away, he's creating a copy of it here. It's probably a best practice. And I could definitely get behind that. I think it's clone. And then we're setting a lifespan. Now, Love2D does have a particle system built into it. And I was sort of taking a look at it, but it looks like here we're creating our own particle system and sort of for learning purposes. And then later on I can go and learn Love's version of it and see what other cool things I can get from it. Okay, so he's setting this to 255. With the idea being that this is how long this particle is going to survive until it is dead. Then we're going to have a run, so as an update and display. Now, the reason why he does this separately here is because in processing, the language that this is built in, they only have draw as in the main file. But we have update and draw, so we don't need to have this run here. We're just have an update and display separately. Display first. Okay, so stroke is 0, lifespan. Interesting. What does that look like? Oh, it's fading out. Right, it's becoming closer to 0, it looks like. No, 255 is white. That's probably the alpha then. Look up what processing does with that. Interesting. There's several different ways you can use it, but yeah, it definitely looks like that's the alpha. So how do I set the alpha? Right, because set color takes that. So if I have equals we can do, he always uses sort of this dark gray. Well, this says it's black, which is interesting because his display is stroke and fill is 0. But I could do that. I could just say, this is going to be the opposite. I want it to be 255. Okay, so we'll set the color there. Right, and then I need this to be okay, this is going to be T dot. So hopefully that should make it sort of fade out as time goes on. That's just all the display we care. Oh, I guess the circle. This is going to be a fill. We're also going to give it self dot y and its size. Self has his as 8. I will try that and we'll see whether or not it's way too small. Okay, we have our update then. Now this is probably going to take delta time. So it looks like we're going to say, okay, we're just going to velocity add acceleration, location add velocity. So we're going to say self dot acceleration plus self dot velocity. Previously we were resetting acceleration, but we're not going to do that anymore because we want it to continuously accelerate down. And then we're also going to reduce the lifespan. So self dot lifespan equal and minus every tick. We're going to reduce it by 2. I can't help but feel that this might be too fast and it's just going to disappear really quickly, but let's see what our frame rate actually is. Then we need an isDead. So all this is going to do is it's going to check to see the lifespan is if this is less than 0. If lifespan is less than 0. Oh, right, because it's isDead, not is alive. So isDead, so if self dot life is then or equal to 0, then return true, else return false. And that's it. Hi Chantilly, welcome to the stream. Okay, so that handles this particle here. In main, we need to bring in vector and particle. And then I know we're going to need the particle. Now he calls his P, but I'm going to call it, well, I don't need anything equals right now. I will need the width. So stop get. Height, and we also need to set the particle. We're going to set this equal to a new particle.new, and we need to hand it where it is that we're starting from. So they have here, like in the middle down by 10 pixels. That's why it's like right here. And I think we can do the same thing. So, cool. And then it's going to be 10. And then in our draw, here he's setting the background again. We don't need to do that because it's Love 2D. We're going to run the particle. So in this case, we're just going to display the particle. And then we're going to check to see if it's dead. We're going to print to here particle dead, probably just to show us that it's actually working. I don't think we need to do that in draw here. Looks like he's not actually cleaning up the particle, which I think is a little bit interesting and probably a bad practice. Although I think later on he does go through and deleting them from the array. But I guess we're only creating one. I guess we're only creating one. So let's do it's going to display, and then okay, so first things we need to limit the delta time. So if dt is 9, then dt set dt equal to 0. Okay, so now that that's out of the way, we want to update the particle. Update, pass it delta time probably. I just realized we're not really using delta time in there, are we? We'll probably want to. My guess is this is going to be really fast. Then what we can do is we'll do this entire print screen to print it to the terminal here when it dies. So we'll just say if particle is dead, print smiley face. And I don't think there's anything else for us to sort of do here, so save the file and let's run it. Attempt to call field new a nil value. Fine. Particle equals particle.new. I've done this several times now. Particle.run instead of particle.new. Let's change that and see if that fixes it. Attempt to index local location on number value. Okay. Particle line 12. Oh, wait a second. Main. Right, because I just say this here, what I really need to say is vector.new and actually pass it the location vector. Particle died. Okay, so that was really fast. So let's figure out where to use this delta time. So we bring it right here. I think that we should time delta time right here. So it's reducing down by a really tiny amount. Save that. Okay, so one thing that I noticed here is that it kind of was working, like it was falling down. And if I and it is going to different locations on the screen, so that's really cool. What I'm not seeing is the lifespan go down. Or rather, I'm not seeing that this set color actually work. So what I'm going to do is I'm going to change this to T dot, what is it? Red, green, blue, red. Okay, now in this self color, we can change this, say self dot red. Self color actually take three things. I now forget. I'm second guessing myself for this. All right, love dot graphics. Set color. Okay, so it just takes those things. So red, green, blue, self dot. And that is going down, so that should be good. Save that. Ha! It died before it could get down here. Okay, so this 2, I'm going to also multiply this by dt to make it a lot slower. And let's increase this speed down. So make this 5. Which means that this may need to be higher than a lot higher than that. It's not dead even yet. Okay, that acceleration is much faster. Or no, our lifespan is much slower. $150? Oh, that's too fast. Okay, there it goes. So one thing I want to do, I've set this velocity to have this random one like this. I'm thinking that this is a little bit too much, so maybe maybe negative. Maybe this one should just be -1. And then also, I'm thinking I want to set this a little bit farther down than just 10 pixels down. Let's set it 30 pixels down. Okay, there we go. Now we see it get created and start falling down. That's nice and cool. But that's not all we really want to do, because a single particle is not really worth much at all. We probably want to have an array. Now, here's where it gets a little bit easier to deal with in Lua and Love2D than it does in processing, which is a Java language. They have to use an array list in order to make sure, like, to be able to add an unknown quantity of these things, whereas I can just use a table because we don't apparently care about that kind of stuff. We're a little bit higher level in language, so I don't need to worry about like doing all this stuff. I'll just set a table and add things in. And it looks like what they're doing is just creating 10 of these. And it looks like every frame. No, oh no, never mind. In setup, so in setup, they're creating the 10 particles, they're adding them into the array, and then in draw, they're just drawing them. Okay, so let's do that. Let's say particles. Okay, so we're just gonna say dot insert particles and just gonna be particle.new. Get over there. Okay, then we'll just put our particle new. And then in draw, we need to have another for loop. So for index particle in this, and we'll just put that here. I don't think we actually need this isDes anymore. We're just gonna spam a whole bunch of things for us. I can just end this right here. I have a problem here. Line 16. For, oh, where's that dot from? Line 1. Vector equals require vector. That seems right. Oh, line 24 now. How did I get that dot? Okay, that went away. Let's come back in here. Not still running. Oh wait, you are still running. That felt like it did not create 10 of them, but I think that's because it's a random direction. and several of them chose the same direction, which this to me, I mean, this is cool and all, but not exactly what I was hoping for. So I don't like the idea of doing this right here. What I do like the idea of is inside of here just saying maybe like add particle, and then we can come here, do that. So that. Okay, so add particle with new. This will be the X and the Y. Here we're just going to simply say table dot insert particles particle dot new X vector dot new X Y, just like that. So I don't actually want to do this here, but I want to verify that I haven't broken it and it's still exactly the same. It is. Perfect. So I don't actually care about doing this like that. What I really want to do is an update here. I want to now say add particle and give it, I want to give it the middle, so it's 2, and then the Y is going to be 30 down. So this should just constantly add new ones every single frame. And that's actually pretty cool. It's like a little water fountain. Let's take a look what the book was suggesting that we do, because I may have diverged slightly from that. Okay, so here it is particles add. So here he switched to adding a new particle to the array every single frame. So that's exactly how we're going. Fireworks, yes, it kind of is. Run the above code for a few minutes and you'll start to see the frame rate slow down. Yes, that's because we're adding all these particles every single frame and we're never cleaning them up. Okay, and so here's where we remove it. So we have to use the table remove, which if I remember correctly, table remove takes the I, and we conveniently have access to the I. So something that would be, I wonder if I can set this up. I remember, I forget the exact syntax. To get the number, so it's Lua table length. Get n. Okay, so I want get n. Wrong one. In main I want to simply display right here in draw. I want to say set color. I can make this white. Of dot graphics dot, I think it's text. I want to give it the text itself, which is going to be particles dot n. No, it's table dot get n, and I'm gonna pass it particles. The X, so I'm just gonna put this right up here in the top left, so I can just set this to like maybe 5 and 5. Let's see if that works. Attempt call. Oh, it's not text, it's print. Okay, so now we can see this the number of particles shooting upwards, but it's never going down. Yeah, actually, now that you mention it, Chantilly, I definitely could make this into a fireworks. If I just fire several of them off and then have them have a really short lifespan, maybe with some random colors, and then just like attach these in different places. That would work. But what we need to do is we need to make sure that these particles do die and get rid of. So I wanted to display that so I can know if I do this correctly here. So in particles update, after this, I want to say if particle is dead, then what I want to do is I want to say table.remove, and it's going to be the table, so particles and then I. That should do that. So we should see this number start to go up, and there it is. So it hits around 153, 154, and then starts, it's cleaning them up because they're dying right around this area. Perfect, okay. There. So that kills the particles. Make sure that our computer can now just run this forever now. See, then he okay, then he talks about what would happen if you wanted to add to the particles in the middle of the loop. So as we're looping through this, add to the particles. And that seems like a really terrible idea. Because of course, it never ends. The table just continuously gets bigger and it just goes on to the end. Okay, so it looks like ArrayList and processing has a generator type object where we can do like get next and basically loop through that. But then he creates this entire thing. So let's see if we can recreate this, sort of closer to how this looks. Because right now this is close, but I think he's jumping out, but only some of them jump out, and way more of ours are jumping out than we actually want it to. So in particle, we have acceleration, we have velocity. I mean, one thing we can do is make sure they're moving, make sure the velocity is moving a lot slower. Acceleration, I think, is good. It feels like it's around the same rate, although I can make this slightly bigger if I needed to. They are moving way far out the beginning, so the initial velocity is not really what I wanted to have. So if I say something like negative 0.0 dot, let's try 0.1. Let's try that and see if that changes it. Looks like a sparkler. Yeah, it kind of does. This one, however, this is not what I wanted. Okay, so what's going on here? Our x-axis for this new like predetermined velocity is going from negative 0.1 to 0.1 on the x-axis. So it's going barely left, a little bit right, but the up is going maybe a little tiny bit up. I can set the up to maybe 5. What I don't understand is why this right is here like this. Why is these ones always going a little tiny bit to the left? This one's going way to the right. So my velocity x only has a chance to go to 0.1. Oh. Oh, this is the y. This is the x, which is just y down. I mean, some of them are going in between here. I can't help but feel this might be a weird random number thing. Way more of them are heading right down the middle a little bit. Now it could be that this delta time is screwing me over, so I can play with that maybe, and just remove it. So then let's try replacing that with 1. Let's bring this back to I think it was -2 to 2. Okay, so if I don't use delta time, I am definitely going to have to figure out a way to set the acceleration. Maybe the acceleration. We can do that. Hey, that looks pretty cool. I want to move this down a little bit more. When I create this, it's down by 70. This is even more like fireworks now. Okay, so we have that. Our lifespan is going down. This delta time, that's hitting velocity plus acceleration. This is our initial velocity that's being hit here. If I set this to -1, what happens? It doesn't shoot out as much. So I want it even lower. So I think this is where I'm having trouble. When I try to set it equal to a really tiny number, is where I get these weirdness like this. So maybe the best thing to do, let it create its own number between 0 and 1. No, I want a number between -1 and 1, but then I want to scale this. So I'm going to say times 0.5 to cut that in half. Hi, Mr. Mondo. What program am I using? I'm using Vim for the editor, and I'm using the Lua language with Love2D to display these. Okay, this is a lot closer, so I definitely need to work on the scaling a little bit. And then I want to do something similar, place that with -1 so it doesn't go quite so high. The only problem I really have with this is that it feels so uniform. This one actually does look random. This is just I was hoping to get let me get something else here. Maybe I can change the location of the delta time around. So if I don't put it there, if I just add the acceleration and then to here I multiply delta time. Maybe I can put these back to 2 again. I just finished a course with MATLAB. I'm studying chemical engineering. What programs do you recommend? Oh man, it's been a while since I've been to college, and I never really did the computer science track. So I'm not sure like too many of the computer programming classes. If you're interested in the kind of things that I'm doing right here, a lot of this is in probably in game development or some kind of animation courses. Although computer animations, like not using 3D tools, is just using code itself. What I'm doing right now is coming back and learning this by going over the Nature of Code book, which is something online that I found, and it's been a lot of fun. It's a course out of New York University. Let's try that change and see what happens. Okay, opposite problem. I created a waterfall. So I need to make these bigger. But I like where this is going. It looks like I might be on the right track here. So if I make this 5, I don't even think these are going up at all. A little bit closer, need a lot more. Maybe I should make this. Oop. See what happens if I make this 50 and 50. Yep, have a great night. Hey, look at this. This is getting a lot closer to what it looks like. So I'm creating a huge number of these. They're all falling down. They get new alphas. Yeah, this is kind of like bubbling water almost. And then to maybe help this is start that. Maybe do this a little bit opposite. So maybe have like 30 here, but this one could be negative 50. Yeah, this looks pretty right, pretty spot on. And then if I wanted to sort of make it like fire, that would be different tones of red, I think. So I can set the greens and blues to 0. That does give me red and sort of fades away, but maybe what might be nice is changing this to love.math random and give it between maybe like 5. Kind of looks like smoke. I kind of want to change its size to like 1. I have no idea if you can see this at all. I'm gonna check my my preview here as soon as it updates. Too tiny, yeah. I can barely see that. Let's make it slightly bigger. Like, I mean, so it does create this. It kind of almost looks like fire. Maybe the opposite because it's flowing down. But I can definitely see how this can be used to create fire or other things. I can go back to 8, which is what we had before, and I can also set this be a little bit brighter, maybe 100. Cool. Okay, I'm just gonna make it a random color. Let's see how this looks. It's cool and all, but it's maybe a little bit too crazy looking. I think the best bet would be to use Perlin Noise. Have the colors change in that way. Okay, T dot X off equals. We should get this be a random number, so method. 0 and like 50,000. This needs to be Y off and Z up. T dot increment equals 0.01 to make it really, really, really different here. So I don't think I need these colors anymore. What I do need to do is in display, or rather, it's gonna be display. I guess what I'm gonna do is I still need T dot but I'm not going to do anything with them right now. Instead, what I'm going to do is in update here, I'm going to first get the Perlin Noise for X off and then set that to green. I have to scale it up. So I'm going to say self.red equals love.math noise. And here this is gonna give, I have to give it the X off, so self dot off. Then I need to increment, sorry, then I need to scale it up by 255, and that should give me self.red. I want to do a very similar thing to green. Except this time, instead of just self.x off, I want to also say self.y off. Finally, blue. For the third dimension of Perlin Noise, here say self. And then finally, I need to increment all these. So self.x off equals x off plus self dot increment. It's going to be y off, replace. Okay, what did I do? Syntax line 20. T dot green. Oh, this needs to be set to something. So I'll just set these to 0. Okay, that should be happy. This should increment it. This sets red, green, and blue. This should slowly change that as they go on, so it's not quite as crazy. Or at least that's what I was hoping to do. What happened? Self dot red equals left dot math the noise. Those are incrementing. Are they incrementing too slowly? I have the times 255, x off, y off, z off, x off. And we can try increment this slower. Oh, that made it crazier. I wonder if I need to use. I'm gonna test something here. I want to see if I get rid of the other dimensions here. I mean, this should make it all exactly the same, which is, I don't think what I really want, because that should make it gray. Right, and that does make it gray, and it should change intensity over time. Let's change it, make this a little bit faster. Okay, yeah, it is doing that. It's sort of changing intensity over time. And that's really cool, but not what I was going for. Maybe in here I can just do self.x off multiple times. Oh, that definitely doesn't work. I mean, what I could do is maybe set x off to be random between these, and then with y off, we're going. Oh, it's because, okay. It's because every single time we create a particle, it's so different because it's a random between 0 and 5,000. I think that might be what the problem is. So what if I did only between 0 and 50? Okay, I want to undo until I have back to how I had them before. So x off, y off, z off. Let's make this a much smaller number here. Okay, so the idea here is every single particle has a really good chance of being very close together on the graph of the random numbers that is Perlin noise. And then as they increment together. So they should all be similar in color. Unless they're not. This is still too... Still too far apart? I mean, I can even just do normal random between 0 and 1. I saved that, right? Oh yeah, I definitely did. So I feel that maybe the problem is that because each one has a chance of being exactly the same. If I scale it down by half, okay, I feel it's still it's a lot better. Scale it down. Do I want to go to like 0.9 or 0.2? This is definitely something I want to look into a little bit more, but I don't want to spend too much time on this. Although it is 9:10 now, which is close to our ending time. But this is a really cool system, although now I can definitely see these colors pop up at the front because of how different they are. Not necessarily the coolest thing in the world. I would love to have it be very similar. Maybe I'll work on that and figure it out. The next part of this would be the particle system class, which I think is doing this exact same thing, but creating a class to then hold and manage all these particles. So then what I could say is create objects from those classes and say like, here, put one here, put one here, put one here. And then it would handle all this stuff in main would just go into the class, and I can just say, hey, create another instance and like put it right here, and I can have a whole bunch of them on the screen. And then, yeah, and then it goes into like creating particle systems wherever you click. So that is coming up. Which I mean, that won't really be a problem. Okay, so we're pretty much reaching the end of the stream time. I'm gonna sort of put this back to the previous, just maybe like one color. I think that looked a lot better. Don't need those. Let's make this like 200. Okay, let's see how this looks. I probably don't need to scale this as much. Really light blue and make this darker. There we go, back to our sort of smokish color.